ಹೆಂಗ್ ಮಾಡೋದಪ್ಪ? ಸಿ ಎಸ್ ವೆಬಿನಾರ್ ಪ್ರೆಸೆಂಟಿಂಗ್.
ಒಮ್ಮೆ ಪಿಪಿಟಿ ಓಪನ್ ಮಾಡಲ್ಲ.
ಪಿಪಿಟಿ ನಾನು ಈಗ ನಾನು ಸ್ಕ್ರೀನ್ ಶೇರ್ ಮಾಡ್ಬೇಕಾ?
ಹೌದು, ಸ್ಕ್ರೀನ್ ಶೇರ್ ಮಾಡಬೇಕು. ಮೊದಲು ಪಿಪಿಟಿ ಓಪನ್ ಮಾಡಿಡು.
ಓಕೆ, ಓಪನ್ ಮಾಡೀನಿ.
ಓಕೆ, ಈಗ ನಾನು ಪ್ರೆಸೆಂಟ್ ಈಗ
ಪ್ರೆಸೆಂಟ್ ಅಂತ ಬರುತ್ತಲ್ಲ,
ರೈಟ್ ಮೋಸ್ಟ್.
ಸಿ ಎಸ್ ವೆಬ್. ಓಕೆ, ಸಿ ಎಸ್ ವೆಬಿನಾರ್ ಪ್ರೆಸೆಂಟ್ ಅಂತನಾ? ಓಕೆ, ಶೇರ್ ನಾವು. ಓಕೆ, ಶೇರ್. ಓಕೆ, ಕಾಣಿಸಕತ್ತದ್ರಿ? ನನ್ನ ಸ್ಕ್ರೀನ್ ಕಾಣಿಸಕತ್ತದ? ಹಲೋ,
ನಂದ್ರೆ ಇದು
ಸೊ ಪ್ರೆಸೆಂಟೇಷನ್ ಇದು ಕೇಳಿಸಕತ್ತದ ವಾಯ್ಸ್? ನಿಮ್ದು ಮ್ಯೂಟ್ ಆಯ್ತು ಅನ್ಸ್ತದ.
ಅವರಿಗೆ ದೊಡ್ಡ ಮಾಡೋದು.
अभी क्या आवाज आ रहा है सर?
ಹಲೋ ಸರ್.
ಸರ್ ಕೇಳಿಸಕತ್ತದ?
ಹಾ ಸರ್, ಕೇಳಿಸ್ತಾ ಇದೆ ಸರ್.
ಹೇಳಿ
ಸರ್. ಅಟ್ ದ ಬಾಟಮ್ ಸ್ಟಾಪ್ ಶೇರಿಂಗ್ ಅಂಡ್ ಹೈಡ್.
ಸ್ಟಾಪ್ ಶೇರಿಂಗ್ ಅಂತ ಹೊಡಿಬೇಕಾ, ಹೈಡ್ ಅಂತ ಹೊಡಿಬೇಕಾ?
ಸರ್ ಹೈಡ್ ಅಂತ ಹೇಳ್ರಿ, ಅದು ಮಾರ್ ಹೋಗುತ್ತೆ.
ಓಕೆ, ಈಗ
ಕ್ಲಿಕ್ ಮಾಡಿಲ್ಲ ನಾನೇನು
ಮಾಡಿದೆ
ಸರ್. ಅಟ್ ದ ಬಾಟಮ್ ಸರ್, meet.google.com is sharing your screen. Stop sharing and hide ಅಂತ ಅದಲ್ಲ ಸರ್, ಹೈಡ್ ಅಂತ ಪ್ರೆಸ್ ಮಾಡಿ ಸರ್.
ಮಾಡಿದೆ ರೀ ಆಗ್ಲೇ.
ಇದು ದೇವರಾಜ ಬಾಟಮ್ ನಲ್ಲಿ ಹೈಡ್ ಅನ್ನ. ಓಕೆ ಸರ್, ಗಾಟ್ ಇಟ್.
ಅದೇ ಭಾಳ ಡಿಲೇ ಅದ ಅನಿಸ್ತದ. ಸೊ ಹೈಡ್ ಕ್ಲಿಕ್ ಮಾಡಿ ಸ್ವಲ್ಪ ಎಷ್ಟು ಆದ್ಮೇಲೆ
ನೀವೇ
ಓಕೆ
ಇದನ್ನ ನೀವು ಟೆಸ್ಟ್ ಮಾಡ್ರಿ. ನೀವು ಸ್ಟಾರ್ಟ್ ಮಾಡ್ರಿ. ವಾಯ್ಸ್ ಮಾಡಿ ನೋಡ್ರಿ ಕ್ಯಾಮೆರಾ.
ಹಲೋ ದೇವರಾಜ್.
ಹಲೋ ಹಲೋ
ದೇವರಾಜ ಕೇಳಿಸ್ತಾ ಇದೆ? ಈಗ ಕಂಫರ್ಟಬಲ್ ಅಲ್ಲ?
ನಿಮ್ದೇನೋ ಒಂದು ವಾಯ್ಸ್ ಬರ್ತದೆ, ವಾಯ್ಸ್. ಓಕೆ, ಈಗ ನೀಟ್ ಆಯ್ತು. ಅದು ಟ್ಯೂನ್ ಅಂತ ವಾಯ್ಸ್ ಬರಕತ್ತಿತ್ತು.
ಸರ್, ದ ಪ್ರೊಸೀಜರ್. ಹಲೋ ಸರ್.
ಹೇಳ್ರಿ. ನನಗೆ ಕೇಳಿಸಕತ್ತದ ಹೇಳ್ರಿ.
ಇವ್ರು ಕೇಳಿಸತ್ತಲ್ಲ, ಅವ್ರು ಕೇಳಿಸತ್ತಾಗಿತ್ತು. ಇಲ್ಲೇ ಆನ್ ಮಾಡ್ರಿ ಸರ್.
ಈಗ ಕೇಳಿಸ್ತಾ ಇದೆ ಸರ್?
ಅಲ್ಲ, ನೀವು ಕನೆಕ್ಟ್ ಅದ. ಹಲೋ ಸರ್.
ಹೇಳ್ರಿ.
ಸರ್, at the beginning, one of our faculty member will be giving a introduction about our college. Then he will be giving a brief introduction of viewers. Then the session will be handed over to you.
ನೋ ಪ್ರಾಬ್ಲಮ್ ಸರ್. ಸೆಷನ್ ಹ್ಯಾಂಡ್ ಓವರ್ ಅಂತಂದ್ರೆ ನಾನು ಏನ್ ಮಾಡ್ಬೇಕ್ರಿ ಅವಾಗ?
You start your presentation then, sir.
ಈಗ ಓಕೆ, ನಾನೇನ್ ಮಾಡ್ತೀನಿ ಅಂದ್ರೆ ಹೋಗಿ ಪ್ರೆಸೆಂಟ್ ನಾವು ಅಂತ ಇಲ್ಲೊಂದು ಬಟನ್ ಅದ, ಅದನ್ನ ಹೊತ್ಬಿಟ್ಟು ನಾನು ಸ್ಕ್ರೀನ್ ಶೇರ್ ಮಾಡಿ ಪ್ರೆಸೆಂಟ್ ಮಾಡೋದು ಅಷ್ಟೇ.
Yes sir.
ಓಕೆ ಓಕೆ. ಅದೇ ಸ್ವಲ್ಪ ನನಗೆ ಈಗ ನನಗೆ ಸ್ಲೈಡ್ ಕಾಣಿಸಕತ್ತದೋ ಇಲ್ಲೋ ಅಂತೇಳಿ ಯಾರು
We'll give you the confirmation, sir.
ಕೇಳಲ್ಲ ಅಥವಾ
No sir, we'll give you the confirmation.
ಓಕೆ, ನಾನು ಯಾರ ಹೆಸರು ತಗೊಳ್ಳಿ?
One of our person will be here, sir, who is acting like a controller. He will be in touch with you during the entire presentation, sir.
ಓಕೆ ಓಕೆ. ಅಲ್ರಿ, ಈಗ ನಾನು ಫಾರ್ ಎಕ್ಸಾಂಪಲ್ ಕ್ಯಾನ್ ಯು ಸಿ ಮೈ ಸ್ಕ್ರೀನ್ ಅಂತ ಕೇಳಿದ್ರೆ, ಸಂಜಯ್ ಕ್ಯಾನ್ ಯು ಸಿ ಮೈ ಸ್ಕ್ರೀನ್ ಅಂತ ಕೇಳಿದ್ರೆ
Sanjay sir will respond to you.
ಓಕೆ ಓಕೆ ಓಕೆ. ಬಿಕಾಸ್ ಅವ್ರ ಹೆಸರು ಕಾಣಿಸಕತ್ತದ ಇನ್ಯಾ ಅದಕ್ಕೆ. ಓಕೆ, ಅವ್ರು ಸಂಜೆ ಅವ್ರ ಕಾಣಿಸಕತ್ತದ್ರಿ ಸೈಡ್ ಅಂತೇಳಿ ಅವ್ರಿಗೆ ಕೇಳ್ತೀನಿ. ಓಕೆ, ಸೊ ಕೇಳಿದ್ಮೇಲೆ ಇದು ಮಾಡ್ಬೇಕು, ಆಯ್ತಾ?
Yes sir, we'll do it sir.
ಓಕೆ
Sir, right now what we have done is for the first 250 members we are making them to get connected through the Google Meet, and for others we are streaming it through the YouTube live.
ಓಕೆ ಓಕೆ, ನೋ ಪ್ರಾಬ್ಲಮ್. ತೊಂದರೆ ಇಲ್ಲ. ಸೊ ಲೆಟ್ಸ್ ಸಿ. ನಾನು ಇದು ಪ್ರೆಸೆಂಟೇಷನ್ 2-3 ದಿವಸದಾಗೆ ಹಾಕಿನಿ ಇದನ್ನ. ಸೊ ಇಟ್ ಶುಡ್ ಬಿ ಗುಡ್. ನನ್ನ ಹತ್ರ ಒಂದು 55 ಸ್ಲೈಡ್ಸ್ ಅವ.
Okay sir.
ಐ ಶುಡ್ ಬಿ ಟೇಕಿಂಗ್ ಅರೌಂಡ್ 40 ಮಿನಿಟ್ಸ್ ಆಗ್ಬೋದು. ಸೊ ಒಂದು ವಿಡಿಯೋ ಎಂಬೆಡ್ ಮಾಡೀನಿ PPT-ನಾಗ. ಸೊ ವಿ ವಿಲ್ ಗೋ ಥ್ರೂ ದಟ್ ಪರ್ಟಿಕ್ಯುಲರ್ ವಿಡಿಯೋ. ಅದನ್ನ ಬೇಕಾದ್ರೆ ವಿಡಿಯೋ ಪ್ರೆಸೆಂಟ್ ಮಾಡೋ ಟೈಮಲ್ಲಿ ವಿ ಕ್ಯಾನ್ ಹ್ಯಾವ್ ಇಟ್.
Right now we will do that video testing also, sir. If you can able to play now, present your screen,
okay.
Start playing that video. We'll see whether that also testing this gets over.
ಓಕೆ, 1 second. ಪ್ರೆಸೆಂಟ್ ನಾವು ಇದು PPT. ಓಕೆ, ಲೆಟ್ ಮೀ ಪ್ರೆಸೆಂಟ್ ವಿಂಡೋನ ಪ್ರೆಸೆಂಟ್ ಮಾಡ್ಬಿಡ್ತೀನಿ. ನಾನು PPT ಕಾಣಿಸಕತ್ತೈತ್ರಿ ನಿಮ್ಗೆ?
ಇಲ್ಲ ಸರ್, ಜಸ್ಟ್ ನಾವು ಪ್ರೆಸೆಂಟೇಷನ್ ಸ್ಟಾಪ್ ಮಾಡ್ತೀವಿ ತಡಿ ಸರ್. ನಮ್ದು ಪ್ರೆಸೆಂಟೇಷನ್ ಸ್ಟಾಪ್ ಮಾಡ್ತೀವಿ ಸರ್.
ನಾನು ಶೇರ್ ಮಾಡ್ತೀನಿ. ಶೇರ್ ಮಾಡಕತ್ತೀನಿ ಇಷ್ಟೊತ್ತು ಮಾತು. ಓಕೆ, ಪ್ರೆಸೆಂಟೇಷನ್. ಆಯ್ತು, ಈಗ ಕಾಣಿಸಕತ್ತೆ.
ಸ್ಲೈಡ್ ಇಸ್ ವಿಸಿಬಲ್
ಸೊ
ನೌ.
ನಾನು ಓಕೆ, ವೇಟ್ ಅ ಸೆಕೆಂಡ್. ನಂದು ಎಲ್ಲ
ಯಾವ್ದಾದ್ರು ಒಂದು ವಿಡಿಯೋ ಇದ್ರೆ ಪ್ಲೇ ಮಾಡಿ ಸರ್, ಅದನ್ನ ನಾವು ಟೆಸ್ಟ್ ಮಾಡಿಬಿಡುವ.
ಅದೇ ರೀ, ಇಲ್ಲದಲ್ಲ ಇದು ಹೈಡ್ ಅಂತ ಮಾಡ್ಬೇಕಾ? ಓಕೆ, ಸೊ ಇಲ್ಲದಲ್ಲ ಇದು ಎಂಬೆಡೆಡ್ ವಿಡಿಯೋ.
ಓಕೆ,
ಬರಕತ್ರಿ
ಸರ್. ನಿಮ್ಮ ಹೆಡ್ಫೋನ್ ತೆಗೆದ್ಬಿಡಿ ಸರ್, ಇಲ್ಲಾಂದ್ರೆ ನಮ್ಗೆ ಸೌಂಡ್ ಬರಲ್ಲ ಸರ್ ಆ ವಿಡಿಯೋದು.
ಹೌದಾ? ಓಕೆ, ಈಗ
ಸರ್ ಫುಲ್ ಸ್ಕ್ರೀನ್ ಮಾಡಿಬಿಡಿ ಸರ್.
ಏನಂದ್ರಿ?
ಎಸ್ ಸರ್, ಗೆಟಿಂಗ್ ಸರ್, ನೋ ಪ್ರಾಬ್ಲಮ್ ಸರ್.
ವಾಲ್ಯೂಮ್ ಬರಕತ್ತದ?
ಹಾ, ಬರ್ತಾ ಇದೆ ಸರ್. ಸರ್ ಪ್ಲೇ ಮಾಡಿ ಸರ್,
Okay.
ವಾಲ್ಯೂಮ್ ಅಷ್ಟು ಇದು ಮಾಡಿ ಸರ್. ಸರ್ ನಿಮ್ಮ ಹೆಡ್ಫೋನ್ ತೆಗಿಬೇಕು ಸರ್, ನೀವು ವಿಡಿಯೋ ಪ್ಲೇ ಮಾಡ್ತಿರಲ್ಲ ಆ ಟೈಮ್ನಲ್ಲಿ.
ತೆಗ್ದೀನಿ, ಹೆಡ್ಫೋನ್ ತೆಗ್ದೀನಿ.
ಬಟ್ ವಾಯ್ಸ್ ಬರ್ತಾ ಇಲ್ಲ ಸರ್ ಈಗ.
ಹೌದಾ?
ವಿಡಿಯೋ ವಾಯ್ಸ್ ಬರ್ತಾ ಇಲ್ಲ ಸರ್ ಈಗ.
ವಿಡಿಯೋ ವಾಯ್ಸಾ?
ಹಾ ಸರ್, ಸ್ಟಾರ್ಟಿಂಗ್ ದಲ್ಲಿ ಬಂತು ಸರ್, ಈಗ ಬರ್ತಾ ಇಲ್ಲ.
ಓಕೆ ಓಕೆ, ಸ್ಟಾರ್ಟಿಂಗ್ ವಾಲ್ಯೂಮ್ ಕಮ್ಮಿ ಇಟ್ಟಿದ್ದೆ. ಈಗ ಬರಕತ್ತದ?
ಇಲ್ಲ ಸರ್. ಸರ್ ವಾಯ್ಸ್ ಭಾಳ ಲೋ ಐತೆ ಸರ್, ವಾಲ್ಯೂಮ್ ಲೋ ಐತ್ರಿ ಸರ್.
ಅದೇ ಅದು ಇಲ್ಲಿ ಪ್ಲೇ ಆಗ್ತದೆ ಅನ್ಸ್ತದ ಅದು. ಓಕೆ, ನೋ ಪ್ರಾಬ್ಲಮ್ ಬಿಡ್ರಿ. ವಾಟ್ ವಿ ಕ್ಯಾನ್ ಡೂ ಇಸ್ ವಿ ವಿಲ್ ಡೂ ಒನ್ ಕೆಲಸ ಮಾಡೋಣ ಹಂಗಂದ್ರೆ. ಸೊ ನಾನು ಈ ಲಿಂಕ್ ಕೊಡ್ತೀನಿ ನಿಮಗೆ, ವಾಲ್ಯೂಮ್ ಈ ಲಿಂಕ್ ಅದಲ್ಲ, ನಾನು ಹೇಳ್ದಂಗೆ ನೀವು ಈ ಲಿಂಕ್ ಪ್ಲೇ ಮಾಡ್ರಿ ಅಲ್ಲಿ ವಿತ್ ವಾಲ್ಯೂಮ್. ನಾನು ಪ್ರೆಸೆಂಟೇಷನ್ ಟೈಮಲ್ಲಿ ಮತ್ತೆ ನಾನು ವಿತೌಟ್ ವಾಲ್ಯೂಮ್ ಐ ಡೂ ರೀಡೂ ದ ವಿಡಿಯೋ ಅಗೇನ್. ಓಕೆನಾ?
ಎಸ್.
Okay, so basically what we'll do is this link you need ನಾನು link
ಸರ್ ಚಾಟ್ ಬಾಕ್ಸ್ ನಲ್ಲಿ ಹಾಕ್ಬಿಡಿ ಸರ್, ನಾವು ತಗೋತೀವಿ ಅಲ್ಲಿ.
ಓಕೆ, ಒಂದು ನಿಮಿಷ. ಹಾನ್ರಿ
ದೇವರಾಜ್ ಕೇಳಿಸ್ತಾ ಇದೆನಾ?
ಕೇಳಿಸ್ತಾ ಇದೆ. ಒಂದು ನಿಮಿಷ.
ವಿಡಿಯೋ
ಒಂದು ನಿಮಿಷ
ದೇವರಾಜ್, ಒಂದ್ ನಿಮಿಷ ದೇವರಾಜ್, ಇದು ನಿಮ್ ಪ್ರೆಸೆಂಟೇಷನ್ 40 ಮಿನಿಟ್ಸ್ ಆಗುತ್ತೇನಾ? ಅದಕ್ಕಿಂತ ಜಾಸ್ತಿ ಆಗೋದಿಲ್ವಾ?
ಮೋಸ್ಟ್ಲಿ ಅದೇ ಪೆಂಡಿಂಗ್ ಆನ್ ಇದು 57 ಸ್ಲೈಡ್ಸ್ ಅವ. ಮೋಸ್ಟ್ಲಿ ಆಲ್ಮೋಸ್ಟ್ 1 hour ಆಗ್ಬೋದು.
ಆಗುತ್ತೆ ಅಲ್ಲ? ಓಕೆ, ನೋ ಇಶ್ಯೂಸ್.
ಅಂದ್ರೆ ನನಗೆ ಟೈಮ್ ನಾನು ಕ್ಯಾಲ್ಕುಲೇಟ್ ಮಾಡಿಲ್ಲ.
ಆಯ್ತು, ಅಂದ್ರೆ ನಮ್ಮದೇನು 1 hour ಡ್ರ್ಯಾಗ್ ಮಾಡಂತ.
ಹೌದು, ಆಗ್ತದೆ 1 hour ಆಗ್ತದೆ.
ಆಯ್ತು
ಸರ್ ಹೇಳ್ರಿ, ಒಂದ್ ನಿಮಿಷ ತಡ್ರಿ ಸುನಿಲ್. ಹಲೋ ಸರ್, ಎಲ್ಲಿ ಇದ್ದೀರಿ? ಬಂದ. ಓಕೆ, ವಿಡಿಯೋ ಲಿಂಕ್ ವಿಡಿಯೋ ಲಿಂಕ್ ಚಾಟಲ್ ಕಳ್ಸಿ ನೋಡ್ರಿ. ನೀವು ಅದನ್ನ ನಾನು ಚಾಟಲ್ ಕಳ್ಸಿನಿ. when I request you just play that video.
No problem, sir.
With volume play ಮಾಡಿ, then I'll take a control back. Okay?
Okay, sir.
ಟೈಪ್ ಮಾಡಿ
ಹಾಕೊಂಡ್ರಿ ಲಿಂಕ್ ಚಾಟ್ನಾಗೆ ಹೋಗ್ತದೆ, ನಾನು ಸೇವ್ ಮಾಡಿ.
Okay, sir. So give me 5 minutes, I'll be coming back. Okay?
Okay, I think with new ID na?
ಇಲ್ಲ ಇದೆ.
Okay.
With same ID only, sir. No problem.
Okay, sir. Okay. ನೀವು ಅದು ವಿಡಿಯೋ ಟ್ರೈ ಮಾಡಿ ಪ್ಲೇ ಮಾಡೋದಕ್ಕೆ. Try to play whether did I send you right ಇಲ್ಲ ನೋಡೋಣ.
ದೇವರಾಜ್, ಒಂದೇ ವಿಡಿಯೋ ಇದೆ ತಾನೆ?
ಒಂದೇ 3 minutes.
Okay.
Cell virtualization is a breakthrough method for increasing cellular capacity without
perfect.
Just a minute, sir.
uses cell virtualization to provide high capacity LTE single cell.
I'll be back in 5 minutes ಅಲ್ಲಿ ಬರ್ತೀನಪ್ಪ. ಓಕೆ
ಓಕೆ, ಪರವಾಗಿಲ್ಲ.
ಅಲ್ರಿ ವಿಶಾಲ, ನೀವು ಪ್ರೆಸೆಂಟಿಂಗ್ ಅಂದಾಗ ಇಲ್ಲಿ ಬರವಾತದ,
ಇಲ್ಲಿ ಬರಂಗಿಲ್ಲ ಸರ್. ಅದು
ಮತ್ತೆ ಎಲ್ಲಿ ಬರ್ತೈತ್ರಿ?
ಅದ ಸ್ಕ್ರೀನ್ ನಮ್ ಶೇರ್
ನಮ್ಮ ಸ್ಕ್ರೀನ್ ಶೇರ್ ಆಗ್ಬೇಕು. ಚಾಲು ಮಾಡ್ರಿ ವಿಡಿಯೋ.
ಇಲ್ಲಿ ನಿಮ್ದು ಪ್ರೆಸೆಂಟಿಂಗ್ ಸ್ಟಾರ್ಟ್ ಮಾಡಿರಲ್ಲ ನೀವು.
ಮತ್ತೆ ಈಗ ಪ್ರೆಸೆಂಟಿಂಗ್ ಐತಿರಲ್ಲ,
ನಮ್ ಸ್ಕ್ರೀನ್ ಇದು ಓಪನ್ ಮಾಡಿದ್ರೆ ಅವ್ರಿಗೆ ವಿಸಿಬಲ್ ಆಗ್ತದೆ ಸರ್.
ಯಾರಿಗೆ? ಈಗ ಐ ಆಮ್ ಪ್ರೆಸೆಂಟಿಂಗ್ ದ ಸ್ಕ್ರೀನ್. ಮತ್ತೆ ಏನ್ ಪ್ರಾಬ್ಲಮ್ ಐತ್ರಿ?
ಇದು ಕ್ಲಿಕ್ ಮಾಡಿರಲ್ಲ ನೀವು.
ಮಾಡಿ.
Comscope's one cell uses cell virtualization to provide high capacity deployment simplicity of the single cell. One cell consists of the basement controller. Performs the basement schedule for a single cell. LTE.
ಅದು ಹಂಗ ಮಿನಿಮೈಸ್ ಇಟ್ಟಿರ್ತೀವಿ. ಆಗ್ಲಿಲ್ಲ ಯಾವಾಗ
Physical resource.
ಯೂಟ್ಯೂಬ್ ಲಿಂಕ್ ಹೇಳ್ರಿ ಚೇತನ್ ಏನ್ ಹೇಳಕತ್ತೀರಿ
ಸರ್ ಮೇಲ್ ಮಾಡ್ತಾರೆ
ವಿಡಿಯೋ ಅಲ್ಲ ಅದು ಕಂಫರ್ಟೇಬಲ್ ಆಗ್ತಾ ಇರಲ್ಲ ಇನ್ನೊಮ್ಮೆ ಕೇಳಿ ಮತ್ತೆ ಸ್ಟಾರ್ಟಿಂಗ್ ನಾಗ ಚಲೋ ಬಂತಲ್ಲ ಇವತ್ತಿಂದಾಗೆ ಚಲೋ ಬಂದಿತ್ತು ಆಮೇಲೆ
ಅವ್ರದ್ದೇನ್ ಪ್ರಾಬ್ಲಮ್ ಇಲ್ಲ
ಮತ್ತೆ ಕೇಳಿ ಇನ್ನೊಮ್ಮೆ ಕೇಳಿ ಮತ್ತೆ ನೀನೇ ವಿಡಿಯೋ ಪ್ಲೇ ಮಾಡ
ಮೇಲ್ ಐಡಿ ಯಾವ ಮೇಲ್ ಐಡಿ ಕಳಿಸಿದ್ರಿ
ಅಲ್ಲ ಯೂಟ್ಯೂಬ್ ಲಿಂಕ್ ತಗೋಬೇಕ್ರಿ ನೀವು
ಅದ ತಗೋಬೇಕಂತ ಅಂದ್ರೆ ಲಾಗಿನ್ ಆಗ್ಬೇಕು ಅಷ್ಟೇ
हेलो
दोनों में एक ही माइक ऑन रखो
नहीं मेरा ऑफ
फोन म्यूट है सर म्यूट है
मेरा म्यूट किया है पहले
ಹಲೋ
थोड़ा उधर लेता है क्या
ಹಾ ನಮಸ್ಕಾರ
मेरे चार्जिंग बंद कर
सर
है ना
ಹಾ ಹೇಳ್ರಿ ಏನಿಲ್ಲ ನೋಡ್ರಿ
स्टॉप ಯೂಟ್ಯೂಬ್ ಹಾಕೋಕ್ಕಿಂತ ಮೊದಲು ಬರತೈತೆ ನೀವು ಹಿಡ್ಕೊರಿ ಕ್ಲಿಕ್ ಮಾಡ್ರಿ ನೀವು ಯಾವ ಲಿಂಕ್ ತಗೊಂಡ್ರಿ ನಾ CSE ಅಂತ ತಕ್ಷಣ ಹೋಗಿಲ್ರಿ ಹಾ ಅದನ್ನ ತಗೊಂಡ್ರಿ ಸರ್ ಎಸ್ ಸರ್
सी ड्राइवर स्लाइड है सर अरे सी ड्राइव सर सर
ನಾ ಬಂದ್ರಿ
ऐसे क्यों हो रहा है दो लाइन बाल सामान
ಸರ್ ನೀವು हम ಬರೋದು ಮ್ಯೂಟ್ ಮಾಡಿ पहिला ಮ್ಯೂಟ್ ಮಾಡಿ
ಇಲ್ಲಿ ಇಲ್ಲೇ ಐತಲ್ಲ ಮತ್ತೆ ಅದನ್ನ ಅನ್ನ ತಗೊಂಡು ಪ್ರೆಸೆಂಟ್ ಮಾಡಿ ಇಟ್ಬಿಟ್ಟು
ಏನು
ಸ್ಪೀಕರ್ ಆನ್
ಏನ್ ಮಾಡೋದು
ಸ್ಪೀಕರ್ ಆನ್ ಅದಾವ
ಎರಡು ಮಾಡ್ತಾರೆ ನೀವೇನ್ ಮಾಡ್ತೀರಾ
ಕ್ರಮ ಇದನ್ನು ಮ್ಯೂಟ್ ಮಾಡಿ
ಅದು ನೋಟ್ ಮಾಡಿದೆ ನೀವು
ಆಯ್ತು
ಅವನಾಯ್ತಾ
ಇಲ್ಲ ಸರ್ ನಿಮ್ಗೆ ಈಗ ಯೂಟ್ಯೂಬ್ ಲಿಂಕ್ ಮತ್ತೆ ಮೀಟಿಂಗ್ ಲಿಂಕ್ ಯಾವ್ದೈತಿ
ಇಲ್ಲೇ ಇದೆ
सभी तीनों ग्रुप में व्हाट्सएप करके छोड़
ಎರಡು ಹಾಕ್ರಿ ಸರ್
ಹಾಗೆ ವಾಟ್ಸಪ್ನಾಗ ಹೆಂಗ್ ಬಿಡ್ತೀರಿ
ವಿಶಾಲ್ ಸರ್ ವಾಟ್ಸ್ಆಪ್ನಾಗ ಹಾಕ್ರಿ ಮೇಲ್ ಹಾಕ್ರಿ ಸರ್ ಟೈಮ್ ಆಗಕತ್ತೈತ್ರಿ
ಅದು ಒಂದೇ ಬಿಡ್ತಾರ ಇದು ಮೀಟಿಂಗ್ ಇದೆ
ಹಾ ಹಾ ಮೀಟಿಂಗ್ ಹಾಕ್ರಿ ಸರ್ ಸರ್ ಬರ್ಲಿ कॉपी लिंक कर सकते हैं तो
सब्जी म्यूट है कुछ भी चल
रविना तो ಓಪನ್ ಮಾಡ್ರೆ ನೀವು ಪ್ರಶ್ನೆ
ಮತ್ತೆ ಯೂಟ್ಯೂಬ್ ಲಿಂಕ್ ಎಲ್ಲಿ ತಗೊಂಡ್ರೆ ಆಗಲೇ ಅವ್ರು ಸರ್ ಕೊಟ್ಟಿದ್ದು ಇಲ್ಲಿ ಇತ್ತಲ್ಲ
ನೀವು ಪೇಸ್ಟ್ ಮಾಡಿರಲ್ಲ
छात्राग ಐತೆ
ಈ ಪೇಸ್ಟ್ ಮಾಡ್ತಾ ಬರ್ತದೆ ಯಾವ್ದು ಪೇಸ್ಟ್ ಮಾಡ್ರೆ ಇದು ನಮ್ಮದು ಐತಿ ಗೂಗಲ್ ಮಾಡಿ ಗೂಗಲ್ ಮಾಡತ್ತ
ಅದು ಅಲ್ಲಿ ನಿಮ್ಗೆ ಆಗಲ್ಲ ಮಾಡಿನಲ್ರಿ ವಿಷಯ
फिर चैट में जो वो रहता है
ಸರ್ ವಾಸನೆ ಹಾಕಿ ಎಲ್ಲರೂ ಎಲ್ಲ ಮಾಡ್ತಾರೆ ವಾಸನೆ ಹಾಕಿನ್ರಿ ಅದು ಮ್ಯಾಗ ಮೀಟಿಂಗ್ ಹಾಕ್ರಿ
ಬಂತು ಸರ್.
ಲಾಸ್ಟ್ ಕ್ಲಿಪ್ ಸೆಂಟರ್ ಹೊಡ್ರಿ ಸರ್
ಏನ್ರಿ ಸರ್
ಲಿಂಕ್ ಕನ್ಫರ್ಮ್ ಆಯ್ತು ಅದಲ್ಲ
ಯಾವ್ದ್ರಿ
ಯೂಟ್ಯೂಬ್ ಇನ್ನ ಪೇಸ್ಟ್ ಮಾಡಿ ಅದು ಮೀಟಿಂಗ್ ಐತ್ರಿ
ಇದರಲ್ಲ ಸರ್ ಇದು ಮೀಟಿಂಗ್ ಆತ್ರಿ ಈ ಕೆಳಗೆ ಯೂಟ್ಯೂಬ್ ಲಿಂಕ್ ಅಲ್ಲ. करता हूँ ठहर बाबा ये लो करेक्ट है वो वैसे दिख रहा है वो
यूट्यूब
ಒಂದು ಕನೆಕ್ಷನ್ ಡಿಸ್ಕನೆಕ್ಟ್ ಆಯ್ತಂದ್ರೆ
ಹಲೋ ಸರ್ ಅದ ಹಾಂ ಸರ್
ಓಕೆ
ಹಲೋ ಓಕೆ ಅಂದ್ರೆ ಒಂದ್ ನಿಮಿಷ ಕಾಣಿಸ್ತಾ ಇದೆಯಾ ಓಕೆ ಡನ್ ಓಕೆ ಡನ್ ಓಕೆ ಬಾಯ್ ಬಾಯ್
ಸರ್ ನೀನೆಲ್ಲ ಟೆಕ್ಸ್ಟ್ ಮಾಡ್ಕೊಳ್ಳಿ
ಟೆಸ್ಟ್ ಐತ್ರಿ
ನೀವು ಎಲ್ಲ ಹಾಂ ಕಷ್ಟ ಸರ್ ಇದೆಲ್ಲ ಮಾಡ್ಕೊಂಡು ಲಿಂಕ್ ಅಂದ್ರೆ ಸಾಕು ಸರ್
from the department got selected for the sponsorship for KCST Bengaluru and 2 projects got selected by McAfee FEAR. The department has well equipped laboratories with all the facilities needed for the VTO curriculum that meets global standard. Now I also take the privilege to introduce today's session 1 resource person, Engineer Devraj Patil sir. Devraj Patil sir did his computer science engineering from PDA College of Engineering, Gulbarga. Then he went on to pursue his MTech from KCE College, Mysore. Sir started his career with Lucent Technologies, where he worked on optical ATM switch, universal mobile technology, telecommunication system. Later on, Sir joined Comscope, where he worked on the tool DMS automation, femtocell, 4G one cell. Sir is now working as a new production introduction team. With this brief introduction, I present before you Engineer Devraj Patil, sir. Sir, welcome you to the webinar. Thank you. Thank you all. I hand over the session to Devraj Patil, sir.
Thank you, Sunil, and thank you, Sami sir. So, thanks for having me here, Sanjay. So, today's I'm really honored that I am having a chance to present my whatever the knowledge which I have, I can share that with you, and this information will be useful as you go along. I mean, the 4G telecom is such a word that everybody uses it. So, for example, everybody has a phone. Everybody is doing meetings online. Everybody is doing TikTok. Okay. So let's start the presentation. Okay. Let me share my screen. So. Okay, so I hope you can all see the slides which are there. So as the, I'll try to keep it very, what do you say, can you guys see my slides? I think Dinesh took over. Okay, I think I am back into the presentation. So, okay, so hopefully you will be seeing the orange color. Welcome to mobility. So we came. I mean, this particular material is majorly sourced from a book. So from a GSM to LTE Advanced Pro and a 5G third edition. So this is available on Orally Technology, I mean on the website. So you guys can go and look at that stuff and read more about this particular. So I have what we're going to do is we will start the presentation with a minor introduction, how the network is, how the 4G network, we are majorly focused on a 4G, and how we are migrating this 4G to a 5G. And everybody knows the advantages of 4G and 5G. So we will
sir, maximize the screen, sir. Full screen.
It is full screen. It is full screen. So on the YouTube, I opened a YouTube in parallel, so I can see that as a full screen is available. So can you see that now? It's a full screen. Okay.
Yes,
so
yes,
now,
we can see.
Thank you, guys. So be free. I mean, be bold enough and talk if you have some questions. So it doesn't harm anybody. It's online. Everybody, we need to get used to this online stuff anyway. So our presence. I mean, like because of the COVID, we need to get more of online. So whenever you get a question, so please feel free to unmute and ask the question. At the end, of course, we will have a question sessions, so where you can ask multiple questions also. Okay, So now let's start with the, what I do is first section will be a major 3GPP model. I'll present the 3GPP model, how the 4G network is planned, okay, from a 2G to 3G, 4G, and how we are in a 4G, how the nodes are there in a 4G, how we achieve this kind of a good data rates in the 4G. Now, later on, at the end of that, we will take a slide deep into the 4G's slightest modification, which is called, I mean, it's not technically a 4.5G kind of thing, but all the 5G quality into the 4G. Now, then later on, we'll go to the 5G itself. So, and in between that, we will touch deep inside the 4G terminologies like PVCH, PVCCH. These are the channels which are used during the data sessions. So let's go to jump into the first slide. So the first slide talks about wireless technologies. I mean, how we came across here, like So we started with the GSM. I mean, before that we had a landline. Okay. So that's a Bell invented, and that's a hello word which came from there, right? So everybody knows about that. So Bell Technologies is still a biggest company in the US. I mean, that of course it's split into multiple companies. Now it's called Lucent. Lucent got into AT&T split into multiple companies, and now still the legacy continues. That's the telecom industry, which is started way back and then continues. So from there we started a wireless world with the GSM, and then we moved on to the GPRS. So GSM and all those stuff were still were still primitive technologies where we are all used to a circuit switching kind of thing. Now we came across to packet switching, then UMTS came, that's properly known as 3G. Okay. So then we got into a long-term evolution. So basically the evolution word is used because when you build an infrastructure for a telecom, you can't replace the whole infrastructure in a single go. It needs to be a way by which you can change your technology. You got 100 installations of your node. Now tomorrow I want to do 5G means you can't take out all the 100. So you should have an evolution from there to go to the next technology. So 3G migrated to a 4G by using an existing infrastructure and still going to provide a lot of speed and data rates and volume of connections. And we are right now in a 4G, and it's a technology got introduced in a 210, but 220 is where it's going to get peak, and probably it will be peak for another 2 years till 2022. I guess the 4G will be top vending technology. Later on that we get a 5G, but 5G doesn't totally replace the 4G, so it's going to coexist with the 4G and 5G, and we will see how it's going to coexist as well. Okay. Now now the question obviously will be asked is, we have a Wi-Fi, why do you need higher data rates? Why can't we use just a Wi-Fi? So Wi-Fi 6, CBRS, these are the other technologies which are coming in the unlicensed spectrum. So there is something called licensed spectrum where, okay, I think I lost my presentation. So as going, this unlicensed spectrum means you need not really buy anything from anybody. So it's a free to use kind of thing. It's like we have water which is flowing in the river. Anybody can tap into that water. But whereas licensed spectrum is where companies spend a lot of money and they buy the spectrum. So which becomes like where it's restricted by the law that you can't use that spectrum. So only, for example, Reliance has brought a spectrum. That means I can't go and disturb that particular spectrum. I'll be held criminally responsible. So that's it's like buying a house. Like if you have a house, only you are allowed to live in that particular one, like that. So when a spectrum is bought by the company, so company, only that particular license holder can deem the signals on that particular stream. So that's where license spectrum becomes more valuable, more trustable, and more controlled. And whereas unlicensed, you have a technologies like a Wi-Fi. Wi-Fi has a 5.2 gigahertz as well, 5.1 gigahertz as well. Now we are coming out with Wi-Fi 6. Now people wanted to do a blend of the Wi-Fi unlicensed and a spectrum, so they got into the CBRS as well. So CBRS gives them a nice blend of an unlicensed spectrum as well as a licensed spectrum. You can combine and still stream it. So these are the different words which we have, but always it's going to be a licensed spectrum going to dominate the market, because it's going to give more trust, more responsibility to the people. Okay. So let me go to the next slide now. So let's see how we came to this 4G world. So we were all used to that circuit switching. So this is what, whenever I ask them questions like, what is the difference between a switching and a routing? So switching and a routing are basically two, it's a typical example. Switch router, everybody knows, they do the same connectivity job. Switching basically is a circuit switching. So you end up wiring a data from one line to another line. For example, if you look at the old movies, people used to take a pin out and plug into the other one. So that means there will be a circuit, will be physical circuit will be created where the data can flow. But in the case of when we come to the packet world, so the packet world is not like that. So packet world gets routed. The packets can come from anywhere, and they have a header and they have a data packet along with data size along with them. So there's a router is intelligent enough to understand where this particular packet need to go, and that's how the technology grows. And by giving this packet to have its own identity and its own destination address, it gives the flexibility for the operators to design their network and automate everything possible in it. And by using that, we achieve more speed, more data, and more packet rates at the end of the day. So this is what 4G itself. 4G is just like 2000 introduced. That doesn't mean that 2010 we had one kind of LTE. Now we are using a 2018. Do we have the same technology in the LTE? Not really. So what we have is the LTE release. So 3GPP has these releases, like we have release 1, delta, beta, alpha, gamma kind of thing, right? So that's how it's going to. So initially 3GPP people released a release 8, where it's going to talk about basic infrastructure and the speed needed for the LTE network. Now they improved and they release one more version called release 10. In that release 10, what they're going to give us is carrier aggregation. So I'll talk about a carrier aggregation anyway. So now you can think that as a carrier aggregation is like you have a tap of the water, okay? Now it's the same, and you are getting a water out of a particular tap. Now if 2 taps give a water to you, then obviously the volume of a water which you receive will be more. So it's like that. So 2 taps combining 2 channels or two individual cells, making it contribute to that increasing your water intake or data intake. So that's how the carrier aggregation comes into the picture. So you have a different carriers and you combine them, aggregate them, and make it a single big pipe. So now you have a 10 ml coming tap. Now you have another 10 ml coming tap. So you combine them, you will get a 20 ml tap. So speed also is like that. So when you combine both of them, you get more data. So now release 13 came in 2015. This is more of a push. A lot of police people uses the still walkie-talkies. So the same thing can be achieved using a LTE network. So it's a push to talk. People like the push to talk. The reason is it's a fast, trustable, and very useful in emergency kind of situations. So that's why the police people or fire department, they all end up using a PTT, which are more trustable. Okay. So now once you go to the again when you come to 2018, we have a release 14 UAs right now available, release 14 of a 3GPP, which says about massive MIMO. So that means multiple antennas which you want to receive. So is going to be increased as well. So okay, so we can talk about the massive MIMO as well. So it's like a number of antennas which you have to receive the signal. So if I take the old technologies, if I take my old example where single tap gives a 10 ml, two taps combine, you give a 20 ml, that is a carrier aggregation. Now you had only one bucket to take the water. Now if you have 2-3 buckets to take the water, then you will have more capacity to storage by yourself. That is how the MIMO is. Like at the receiver side, you increase your span. So you increase instead of receiving the data on one antenna, you receive using a massive multiple MIMO array antenna. So now all these things get migrated to a evolution. So again, you get a 5G. So 5G comes with a new radio itself, and we'll have again big fantastic features there as well. So let's go to the so I moved on to the next slide. I'm watching YouTube so that it refreshes. Yeah, YouTube is good. Okay, so I can see my new slide here. This talks about okay, I lost presentation. Let me get back to the presentation again. Okay, there you go. So I got my hey, good morning. So now we are on a 3 generation partnership project. It's a third generation partnership project, one which is leading technologies right now. So they define how the network should look like. So for example, hello, tomorrow you come up with a new technology.
Is it audible?
Yeah, I can hear you.
Good morning. How are you? You are safe?
Yeah, good. So can you see
us?
Where
are others still coming?
We are in a presentation right now.
Okay, let others.
So let's go to the third generation partnership project. So for example, tomorrow you come up with a new technology, new radio, new way of doing it. Can you go and deploy it? No. I mean, you can't do the things by yourself unless it gets approved by the 3GPP. Why we need a forum like a 3GPP is 3GPP defines a standard for everyone, and they also help so there are too many stakeholders in this whole network. So there's a base station provider, there's an antenna provider, there's a cable provider, there's an internet provider. All of them need to work together, means there should be some standard, and that standard is 3GPP. Now, using a 3GPP standard, they define, it's like a functional spec. They tell how to do the things, how the things should look like. But how you implement, they don't tell it to you. In some cases, they do explain, but most of the cases, implementation is left to them. So, for example, here they define in this particular picture. So, if you look at it, there is a E node B. I'm talking specifically on a 4G. So, 4G has a E node B, and it has a mobile device. So eNode B to mobile device is represented by the LTE UU interface. They give a name, like for everything A, B, C, D. They started, and they now started using a double letters. So UU kind of an interface. So which is basically a link between a eNode B and a mobile. So basically, it defines the standard how the eNode B should talk to mobile, and mobile should talk to eNode B in a 4G technology. And the specifications is like when should the mobile start sending a signal? When should it start attaching? How should it know that there is a network is available in the whole system? Am I valid user to this particular system? Should I go and latch on to this particular system? There is a hell lot of things which are defined in the UU interface. You think about networking. I mean, if you read your networking book, so there's a collision multiple CDMA technology. There's all the stuff comes into this particular picture. So similarly, the eNode we need to talk to our internet. Can it talk to directly internet? No, it need to go through several stages again. It has the eNode B establishes links between MME and a serving gateway, and eNode B to eNode B talking itself through some link called X2 link, and between MME and eNode B they use S1, and between serving gateway to eNode B they use GTP. So there's a lot of things goes between them, and finally when you get to internet, it will be a PDN gateway which talks to the internet. So what we do is we will go through each one of the element here, how it looks like, and how they come. So I'll take each one of the piece and try to explain. Okay. So UU interface. Now, first thing is the speed. When a mobile comes to your hand, and how the speed is what our whole thing is about. So the 3GPP defines as the category of UV. So each release going to release like specification for 2 to 3 categories. So for example, in this table, I have a category 3, 4, 6, 9, 12. These are the categories of the UV, which are defined in the 3GPP, and 12 is probably defined in the release 9, I guess. So in the release 9 of 3GPP, if you look at release 12, category 12 UV, it will tell the specifications what it can do, what it can't do. Okay, so in this case, it can do a bit rate, which is around the 600 maximum downlink data rate with the carried aggregation. It can do a 600 PRBs kind of thing. So similarly, number of uplink data rate can do 100 PRBs. So it goes like that. So number of antennas it can receive is also going to change based on that. So this particular thing defines the speed by which your mobile can receive a data from a network. So as I said, release 8 defined the classes between a 1 to 5. Then release 9, we started with a new, again given new categories. Again release 10, it divides the UVs into a different categories. The one which is like a highest speed in that particular release, to a lowest speed, lowest power consuming, longest running. So they have a different need for the different users. Some people want really fast mobile with the data about a battery life, where, for example, IoT devices kind of thing. So where they want to keep this mobile on all the time, and it will run like 24/7, giving them some signal. So in that case, power consumptions really become critical. So 3GPP takes care of a high power consumption user to a low power consumption user, and they divide the UVs into categories and they separate it. For example, in today's world, we have a fast 64 QAM. QAM is the encryption method they use between in the radio link, by which you can increase the data rate. So higher the QAM, it's like a zip file kind of thing. So higher the QAM, you get a more data rate. So in the UL uplink, that is mobile to a eNode B, it's a 264 QAM. Go up to 64 with the carrier aggregation. Okay. So I just got this latest release thing also. So latest release is, for example, if release 14.15 is also available data more about 5G, but if you look at the LTE standard, we have a data M1 category. M1 is there, which is targeted to the guys who want to keep their mobile on all the time. For example, for a year, they will install a sensor in your building and it will have a LTE connection. And for a year or 2 year or 3 year, people will not even go near to that. The given battery on the 1 year back will continue to serve the signal, and the battery will never die. So because of the power consumption of that category M1. How much signal strength it need to shout at, how much signal strength it can receive. So obviously when you reduce your battery consumption, that means your data rate is also going to come down. So that is also defined in the Cat 1 release 13, even though it's a release 13, but if you look at the data rate, it's 1 megabits per second. So, but in the same release, if you go to the 18, category 18, you see the data rate is going to be really high. And for example, in the 17, it's going to be really super fantastic data rates which you're going to receive. So let me go to the next slide. So as I said, that was about UU interface. So there's people define a standard. There's a standard defined, and now by using this standard, the mobile companies go and implement this standard in their mobile, and they can release it. Now, when it comes to eNode B, eNode B is a one more central piece here in the green color piece. So 3GPP defines something called eNode B, enhanced to Node B. So in the 3G world, it's called Node B. Now that is evoluted, and it became a eNode B. Now, eNode B is again a critical guy here, which has which we just saw the UE interface. Now, eNode B can talk to another eNode B using a X2 interface. It can talk to MME using a S1 interface, and it can talk to STW using a S1 GTP related based interface. So that's how it will be. And they further take down to OPGW and they go to the internet. Okay. So, but our critical piece over here is the eNode B. Now, how it, so it, we know how the UE talks to eNode B, but how the eNode B itself talks to the different elements. So we will go over those things in the coming slides. Okay. So most important thing in the eNode B is since it needs to talk over the interface, over the air interface, it will have an antenna part to it. Mobile also will have an antenna, but they are embedded inside the mobile. They are not externally visible. But the eNode B antennas are more.
Sir, sorry to interrupt. Hello, Mr. Samir Gadkari, please disable your presentation. Mr. Samir.
I think I can take the control. Not a problem.
You take the control, sir.
Okay. Yeah, this YouTube is good, sir. You did a good job. Okay. So we're back to the slides. So as I said, eNode B will have antennas to it. That's what you see, which is mounted over a tower. So when you see the big tower, which is actually mounting a eNode B antenna in it, 4G antenna in it. Okay. So radio modules are used for modulating the data and demodulating the data. So when you want to transfer, so the signal is analog signals which we get over the air. So it need to be converted to a modulation, demodulation using a DSP processing, and electronics people are very good at it, and they do it really good job of getting a over the air analog signal and getting converted to a digital back into the system, because this whole network is a packet, so we live in a bits, not in a analog signal. So digital modulation enables us to get the more speed out of the network compared to the analog one. So ultimately we live in the analog world, but we end up using converting into back to digital. Okay. Now let's understand. It's a good time to introduce something called bearer. So now the bearer is nothing but it's a pipe between you and a internet. Okay. So it goes through several iterations in between. So for example, so this is the who is a consumer of the data, but the internet lies somewhere over here. Now, how in between I have node B, SG node B, PW. So how does this whole thing works? And you will have nowadays we do a VoLTE also. VoLTE has a specific requirement that packet come at a particular given time. If the packet doesn't come at a required time, then that packet doesn't have a value. For example, in a voice call, if somebody talks to you and if it comes really after 5 seconds, it doesn't make sense. That packet is not valid. So that means the quality of service for the voice bearer is going to be different than an internet browsing session. Browsing session doesn't need anything. I mean, the packet can come later. For example, you are downloading one image, one web page. The text comes first. The image can come later. If it comes later, it doesn't really harm your perception. But whereas in the case of VoLTE, it does. So that's the QoS which we have, and it has a latency and a throughput related stuff in it. So now when a UV comes into that, it talks to eNode B. eNode B makes sure that it creates some virtual tunnel that's called EPS bearer here, you see. So which takes you to from UV to the end of the internet with a good quality. Give me a second, guys. Okay, sorry for that, guys. I hope you can hear me. Okay, so now this bearer, which is created, virtual bearer, which is created between here to here. Physically, there is no cable exist. All packets are coordinated such a way that it creates some kind of a stream between a PGW and a mobile, and it provides the minimum latency in the case of voice calls. In the case of data rate, it's going to provide you maximum data rate. The voice also has a good quality that it doesn't consume much of the bandwidth. So the queue size need to be really small, but it need to be fast. But in the case of a data bearer, where you are trying to browse or download a video, the requirement is the bandwidth is more, but the quality of service can be a little bit lower than a voice. So those are the things which will be there in the bearer. So now that is called radio access. That's whole thing is going to be a radio bearer. We're going to have first is radio bearers going to be there, and then it's going to be ERAB bearers will be there in the between the eNode B and STW, and there will be a EPS bearer which is going to be there between a UV and PGW. And finally, you will have an end-to-end between the internet and you, using a end-to-end quality of service. These whole things are split into a small pieces. So when you are talking between a eNodeB to UE, you will use the DRPs, which can be a signaling radio bearer, or it can be data radio bearer. So signaling is used for like how the UE should it increase the power to transmit, or should it reduce the power to transmit, or does it need to do a handover? Because if it is going from a one tower to another tower, it need to do a handover. So I use a tower, but in a physical sense, it can be a single tower. There is eNodeB is getting broadcasted, and your signal from a one eNodeB is getting weaker, another getting stronger. In that case, you end up doing the handover to the other eNodeB. So these all things are controlled by using a mobility management and a radio resource configuration. So radio resource configuration also it plays important role, saying that should I need to, is my signal going down, or is it going to increase, my signal strength is increasing. If it is increasing, I should start saving the power. If the signal is very weak, then I should start using a more signal to reach to the other guys. It's like in a crowded place, you are sitting in a crowded place, and if you want somebody to hear you, you need to really shout loud. But if you're sitting in a single or a silent area in the night, probably you whisper, the other guy can hear. So that means you are saving your energy by just whispering with a low energy, but the other guy is still able to hear you. But in the case of crowded area where you need to really spend your energy, so and that all these things are handled by using a radio resource configuration, which will tell you TPC up or TPC down kind of thing. TPC is for a power increase in the radio signal. Okay. That is the bearer which we talk about. Now, eNodeB itself can talk to other eNodeB. So that particular thing is called X2 interface. So why you need to talk to other eNodeB is to know that where the UE is going from B to another. So if it's going, so obviously eNodeB will be traveling from a eNodeB A to B, which is adjacent to it. It can't travel really far away thing. So that means if I know my environment properly, if the source eNodeB knows who are all around me, then I can do a faster handover by using X2 itself. So that's the idea. So that it maintains a communication between a eNodeB to eNodeB using a X2 interface. And the same thing will be like when you come into the 5G. So will be we have a NSA and SA modes. So there it will be much more useful as well. So another advantage of talking to a neighboring node is load balancing. For example, suddenly in your area there is like 100 of people are coming in, then your radio network really is crammed out. Like a lot of people are jamming into your network. So if there are bordering area, users are there, then you can just offload it into other eNodeB, so that your load is getting reduced and it's easy to manage the resources under your resource. So we do, I mean, the eNodeB is a critical and a major stuff in the 4G network. So it does the radio resource management, it does the user management, it does the handover management, and it can do a lot of things in a given time. So we will cover more about the eNodeB in the coming slides. This is just an introduction where we are trying to do a eNodeB stuff. So eNodeB talks to using a X2 using a neighbor node. Now it wants to talk to a core network element. In the previous diagram, we saw that the eNodeB can talk to SCW, MMEW, MME, all this stuff. How they talk. So there are two planes are maintained at the eNodeB. One is called control panel, and another is called user panel. It's the standard thing which happens all the time. So the control panel talks about like whether the user is a valid user or not. Give me a second. Okay, I'm back presenting. So the control panel talks about the control information, whether the user is valid, when a mobile system comes into your system, we need to validate whether that guy is right or not, whether he belongs to Vodafone or Airtel, or does he belongs to the really high priority user, where he's like a doctor kind of thing, where he needs emergency services. So those are in the particular control. And then, so to do a control plane, what we do is we either use a TCP protocol or a UDP protocol. But in this particular case, we came up with something called streaming control protocol. So streaming control transmission protocol, SCTP, sits above the IP layer. Okay, so and it's a so instead of purely having a UDP or a TCP nature, it will have a special properties so that it can do a better controlling of the signal. Because we are talking to a mobile, which is an air interface, we don't know when that guy going to lose a signal, when he's going to gain the signal. So that whole thing need to be handled smoothly. So that's why we end up using SCTP stuff. Whereas in the control panel, it's a GTP protocol. It's a layer above the UDP. So so nowadays we use a GTP v2, so which is gives a much more data related stuff, and UDP is better because there's no retransmissions are needed in the case of UDP. If you start using a TCP in the or next to the air interface, probably you will never make a single packet out. So UDP makes sure that there's no acts are needed, which will help radio resources to make sure the packets are from one end to other end are reached by using a ARC or ARQ methodology. So they use a much more stricter in the lower panel, a lower L1 layer, so that even though you use a UDP protocol, you will still get the TCP kind of feeling at the user level. So this is I'm talking about the E node B layer. So over this UDP, application may use some other thing. Like for example, they may use a HTTP based or TCP based or some other layer RTP based videos. So they will all be converted back to the packet within a packet. And ultimately, when it goes to the L1, it will be an air interface. When it is in a L2 and IP area, it will be IP packet. When it is in a GTP, it's a UDP packet, which a GTP packet around header. So next is about X2. So X2 is about the E node B to E node B communication, as I said. So you need not. So normally what happens is if you don't have a X2, and if you talk to a, if you don't have this X2 link, so if you want to talk to this node, okay, so the packet need to go all the way to the core, because he doesn't know where this guy is, and he need to go all the way to the top, and then from there he need to send it back to him. Okay. So that's the thing which is going to happen. So if you have a X2 link between them, so then if you want to talk to the next E node B for any reason, like for example, there's a mobile which is sitting right in between that, and this load, the load on this E node B is really heavy, and he wants to offload some of the users to this particular guy, or and otherwise he wants to know the neighbors. What is this particular? What are the other things that our X2 interface? And the another major thing is the RSI and PCI kind of information. So these are the in a radio when you use the OFDM. So you need to make sure that your signal is offset by the other guy using some kind of a network RSI, root sequence index, or PCI, physical cell index, so that they are they are uniquely identifiable and a signal is decoded properly and will be. So for those things, it will automatically use this X2 link. And neighbor relation. So this basically, when you talk to this particular guy, you will also build a ANR database, which is nothing but information about your neighbor. So how far he is from my side. So this is all understood by using a X2 link, and whenever the mobile from here to here it goes here, so they will understand how this using this mobile user in between, they understand how far my signal is good, how far that guy's signal is good. So they understand this ANR information and they help in understanding the overall network. So now we talked about the air interface. eNode B comes into the picture. eNode B2 UE is maintained by a radio frequency, radio signals, and eNode B, whom does it talk to? Control guy. The control panel talks to. So yeah, so MMX or the given a eNode B talks to MMX, but he will not so eNode B talks to MME, but does it like eNode B talks to 1,000 UEs and 1,000 UEs talks to MME. eNode B is a transmitter in between. He doesn't touch any control information. For example, if you build a eNode B, you are not supposed to see what UE is actually sending over a control panel. So that's going to be encrypted, and it's going to be a NAS encrypted algorithms will be used. So even though there is a guy between you and MME who is controlling your identity, your profile, your information, so he will not come to know. I mean, eNode we will never come to know about those things. So he'll be just a pass-through kind of guy for the NAS messages. And eNode B can tap immediately, and this in turn will have a redundancy built into them. So it's like a huge country can be run using a 128 MME kind of a scenario where all of the system can be run. So we are talking about a billion people now, and they talk to MMEs. MMEs get synchronized between themselves, and they maintain this billion people data within them and help in a network. So this is about one particular operator. So each operator going to have its own MMEs again. So and they talk to them using a different interface, and that's a different part altogether. So now, what are the MME responsibilities? What MME is going to do for me? So eNode B gave a UE information to me, what it's going to do. So it's going to authenticate whether that particular guy is right or not. He may use some other guys in between, like HSS, all those kind of thing. So, but he will try to. There's a radius system is also involved in it. So he will talk to different entities in the network and make sure that the user who came through eNode B has access to the ERAP is a valid guy or not. Okay. Now, once the authentication is done, then he will say that you can go ahead and create a data channel or a bearer with a particular QoS with a security gateway, S gateway. So serving gateway maintains your data related stuff. Now, another important thing which MME does is NAS mobility. So NAS mobility includes like where the UE is. So once the data bearer is established, it's not that you just establish a data bearer and give it to him, because the UV is moving all the time, so we don't know where he is right now. So we need to make sure that every 30 milliseconds or 40 milliseconds, we understand where he is, and that particular thing is understood by using a tracking area update. And another thing is, now UV is not doing anything, but he simply went into a dormant mode. But somebody else is trying to reach. There is another UV wants to reach this particular UV, which is not doing any work, which released all its resources, freed up, because he's not using anything. So he will end up releasing all his resources. So he's sitting idle. Now MME maintains one more information called the tracking area. By using a tracking area update, he will maintain the location of this particular UV, even though when he is not active. So when somebody else tries to call him, he will wake that particular UV using a paging. So he will send a specific signal which he knew last time, and Inodi will broadcast this paging information over the air. And mobile also keep listening to this particular paging information. As soon as he hears some page for him, he will automatically establish a data bearer and start reacting to the call, or mobile call, or a data request, or whatever it is. CMAS messages. CMAS messages are nothing but emergency messages which get broadcasted. So after that, we have something called handovers. Coordinate when a UV moves from one area to other area, as part of his mobility. So he will make sure that his data rates, you are receiving a 10 bits per second or 100 megabytes per second, and when you move from one area to another under another node, he will make sure that your voice call continues, your streaming continues, video continues automatically without you re-establishing or without you observing there is a handover happening. SMS and voice support. So obviously voice calls are all routed through this particular MME. As soon as the UV comes into the picture, so he will make sure that he gets a voice bearer if it's a VoLTE supported phone. Okay. So now that was about a MME who controls everything about related to controlling of that particular mobile. Now data itself is not done by the MME. So data is done by using a data bearer, which is established between an E node B, UV, and a SCW. So that interface, you can see it here. 3GPP names them as a LTE UV interface and S1U interface. When a mobile comes in, it will maintain one S1 MME interface and S1U interface for that particular session, and any data which is requested will be going through this particular guy and goes to PGW and then to the internet. Whenever UV comes into the picture, it gets authenticated using a HSS maintains its information about a lot of details, like whether it's his profile, what is his profile, whether he's still a valid user or not, accounting information. All those things are maintained between these two guys, and they authenticate and they grant, and what kind of a data bearer can be established is decided based on that. So PGW, STW takes STW further talks to PGW, which terminates the S connection. That means all the radio, so from here to whatever the packets came here, which will terminate over here. That means the SGW just need to worry about whatever the data comes in here. He need to make sure there's a session maintained here, there's a session maintained here. And we just need to maintain a session maintained here, session maintained here. So SGI will maintain a session between here and here. So by using this all coordinated networks, so ultimately UV will establish a data path from here all the way to the internet. So, and STW also terminates the S1UP GDP traffic. GDP is the packet, UDP passed packet, which is sent between the UV and GDP server. Now, GDP gives, STW gives GDP packet to PDN gateway. So, and converting it into S6, S5 interface. Now, what will happen at the PDN gateway? PDN gateway is where you actually touch the internet. Till that particular time, you didn't have an internet at all. So, PDN gateway is the one which will connect you to the internet, and from there only you can have access to the any network or IMS or VoLTE calls or any external world entity which you want to talk about. Okay. So, and sometimes what happens is some companies maintain a PDN data. So, for example, if you don't know, if you want a company to company link, I can have a PDN network and I can have a unique profile set up like that. That whole data is encrypted and stored securely in my network. So, for example, defense projects can do their own PDN, or regular companies to improve their data quality, they can do a VPN connection between, helps in a VPN connection between the intermediate connection between the IPs. Okay. So, so data packets are always comes from the S5 GTP traffic, then come to STW, then comes to S1 interface, then comes to E node B, then comes to air interface. This whole drama happens beyond our single browsing request or a VoLTE request. So now IMS is a very important thing. If your phone supports the VoLTE support, now as soon as you get a bearer for a data browsing, which is only used for a data related request, but if you want to do a voice, there is a IMS QCI5 and QCI1. These are the two quality of service related bearers will be maintained between your mobile and the network all the time. So, and one of them is used for when you are doing a voice call. One of them is QCI1 and 5. One of them is used for voice related packets. One of them is used for control related packets. So that you are there in the network. If somebody calls you, then a system can recognize using a control bearer, and you can make a call. I'm just waiting for a slide to show up. So now whether the user is a valid or not, whether this is again comes from HSS comes from a 3G world, 3GPP. Even in a 3G world, we had this particular thing. So most of the things contained in the HMS are like IMSI number. So you keep hearing about a IMSI, which is there on your SIM card, right? Subscriber identity module, which will have IMSI number in it, which will identify you in the whole world uniquely, so that people can talk to you, and people can send messages to you, all those stuff. And HSS helps in that particular one. MME talks to HSS based on this IMSI number. It maintains the STIMSI or TIMSI kind of information, and it will maintain a unique connection to mobile. So IMSI will have two parts in it, more important parts called MCC and MNC. So mobile country code and a mobile network code. So these are uniquely identified for a particular operator. A single operator can have multiple MNC and MCC, but ideally they will have a multiple MCC, MNC codes given to their customers. And that, for example, if you buy a SIM card from Airtel, probably it will have a unique MCC and MNC code, which is common to all the Airtel consumers. And similarly, Idea will have its own MNC and MNC code. And if you buy it from AT&T from the US, they have their code. So a copy of IMSI is stored in your SIM card also. That's how when you when you make a call, that IMSI will be passed to the get password with the HSS, and then it will authenticate whether you get authenticated or rejected. If you get authenticated, you will get a connection to the network. So that's how you, if it's a Airtel SIM, always latches onto Airtel network. It can't latch onto the Reliance network. So that authentication is done by using the HSS. Circuit switching services, for example, SMS and call forwarding information is maintained in the HSS. Access point name. So access point name determines how the access for this particular internet access or IMS access will be provided to this particular subscriber is tied to IMSI. So one guy can have a highest priority network. One guy's SIM card will connect to his own company network. One guy's company is X, another guy's company is Y. Then APNs, by changing APNs, by allocating a proper APNs, he can be routed to a particular PDN, and from the PDN he can get into a particular network. So MSC, I mean, under circuit switching calls, for example, if somebody calls 3G world, 3G old 3G phones, or somebody calls from MSC, it comes to HSS, and from there he will identify where he is, and he will forward automatically. He gets routed. So the idea of the SGSN or MME, which is used in case of a user HSS profile is updated, to push the changes to the network elements also. Okay. And during authentication, there is a diameter, there's a radius protocol is used as well. So the diameter which will help you in identifying a particular user, whether it's valid or not. So there will be home location register, HLR will be there, and there's a mobile application part is also used between them, to identify the particular user. So these are all defined in the standard 3GPP world with a 6A interface. Okay. So now the user is authenticated, he is using a network. How does the billing happens? So billing can be a billing or a quality of service or a lot of things related to that particular stuff, right? So one of them example is a prepaid and a postpaid connections. So prepaid and postpaid connections are very they are record based, so there's no limit on them to charge. So what happens is there will be records will be used at the MME. They collect it, they process it on every month, and they will probably every hour they process it, and they will try to give you a data how much to be charged on your connection. Whereas in the prepaid connections are more challenging, where it need to be measured, the user information, whether he's a valid or that did he lose his packet plan. All those things need to be much more stricter in the case of a prepaid connection. So that's automatically maintained during this particular network. MME, SW, PDN gateways, they coordinate, and operator can come up with his own idea. There's no specification which will explain that. There is a guidelines are there, but there's no specification of how you charge the user. So you can charge based on your regular, you can use your own protocol, you can use your own systems. By using these three elements, you combine them, how many pages he went and browsed, or how many data sessions he established. Based on those records, you can go and charge the customer. So that was about a brief introduction about the 4G network. That was just about, we just talked about the elements right now. So we need to understand now how the radio actually works in the 4G. This is again not detailed one. I'll just skim through the different areas which we have there in that radio, and we will see how it works. Sunil sir, how are we doing on time? Are we good?
Sir, tell me.
Yeah, I was just wondering, how are we doing on a timing, time related? So how much time do you have left over?
Sir, last 10 minutes, sir. 10 minutes left. You carry on, sir, please.
Okay. So what we do is, so these are the inside of the, so let me skim through really fast on that one. There's a video which I have at the end, so probably that's what we want to more focus on, which is a live deployment scenario. It will be much more easy to understand.
Yes, sir.
So these
Sir,
are
you
all
finish up this, we will play the video.
Okay. So yeah, this is all available in your textbook. FDM is a orthogonal frequency division multiple access. This is what we use it in the case of a 5G as well as 4G. So this is a technology which is making us really go to the edge and access more out of the network. Compared to the older GSM or UMTS network, where they used to give a dedicated channel to a user. That means there's a frequency is allocated to a particular user, and he need to use that particular frequency only to communicate between him and a network. But in the case of OFDM, the whole frequency is given to the user. So, for example, if you have a 50 megahertz spectrum bandwidth, the whole thing is free to use for the particular user based on the demand which is there at that particular time. So, and that's what we end up using. So in the case here also in the downlink, we use more of a OFDM kind of thing in the case of 4G. So where we signal the radio beams, or else we do a QAM-based encryption and broadcast the signal to the user. So here is the orthogonality what we do. So in the case of this diagram probably explains much neater how the OFDM works, and this is in a 3D. See orthogonality of two nodes. So if there is an X node and there is a Y node, they are sharing the same frequency, but still they can send and transmit a signal without doing a much of an interference to the other signal, and that is using this RSI value or PCI value. So they offset it by themselves so that they skip the clash between them and they go through that. So for example, in this case, so in the OFDM technology, what happens is there is a, let's assume that you have a ABCD pair which need to be sent across over a frequency division. Okay, so we end up using the IFTT, so inverse Fourier transfer, and convert it into analog signal. And then once you convert it into analog signal, it goes to a modulation, which is nothing but a DSP related chip, which will convert it into a air signal. And then on the receiving side, we do a reverse FFT. I mean, it's a FFT. We did an inverse here. We do a regular FFT there and get the signal back. So the subscribers are spaced in such a way that the side lobe of each subcarrier wave are exactly 0 at the center from the neighboring subcarrier. So they maintain that particular orthogonal property so that your signal is reached to the destination with the proper quality without any loss. So LTE uses has a very stricter on subcarriers. So subcarriers are like nothing but a pipes kind of thing within the radio technology. So they are spaced at the 15 kilohertz. This is the standard spacing so that it doesn't, DSP chip can decode a signal when it receives. So you maintain as multiple pipes of the subcarrier, and each have a gap of a 15 kilohertz, so which will give enough space so that the DSP can understand that there's a gap here. I need to decode it. Length of transmission up is like 66.667 milliseconds, and standard cyclic prefix is also maintained, which is of 4.7 microseconds. So, so these all the cyclic preface is transmitted before each OFDM symbol to prevent inter-symbol interference due to different lengths of several transmission paths. So, but in the that was in the downlink, but in uplink, we can't use the. I mean, right now, what we in a 4G technology, we don't recommend to use the same OFDM technology, but in the case of uplink, we use something called single carrier frequency division multiplication, multiple access, that is SCFDMA. So in this case, because there E-node can transmit the signal in a OFDM format and it can be decoded by the UEs which receives it. But when several UEs transmitted data with the OFDM technology and then received at the receiver side, it will be difficult for this to decode. So that's why we end up using this SCFDMA, which is which is so in this case, we do a Fourier transfer and inverse Fourier transfer and send the signal across. Okay. So now, let's see how the modulation. Now we understood the signal comes into our OFDM or SCFDMA technology and then comes out of the network. Now, the pure analog signal is available to us right now. So analog signal can be modulated. Now modulation, when you do it, that's where your data rate is going to increase. If your signal quality is really clean, then that means you can whisper and the other guy can hear you. That means you can bend your signal such a way that it can give a more bits packaged in a particular sequence. For example, if you are able to understand a particular signal is at a 45 degrees, then if it is also at a 30 degrees, if you are able to identify the difference between the orientation of that signal, that means you can package the analog signals in a much more neater way. So you can use a much more these angles to identify the bit rates. Okay. For example, in this picture, what I'm showing is a 16 QAM thing. So that means in a given sequence, I'm going to use a 16 QAM technology and then transfer the data on a single radio transformation. So when you angle this particular data at this particular rate, that means I'm trying to send a 00, I'm sending to send this particular bit, I'm sending to send this particular. So if you're able to send this modulation using a 16 QAM and receiver is able to receive it, that means I'm able to achieve more data rate. Now the 16 QAM can be increased to 256 QAM at the maximum data rates. So now new mobiles which have much more finer DSP chips in them, so instead of just a 16 bits like this, I can have a 256 QAM. That means the same time I can identify a 256 related different bit sequences I can identify and I can receive that kind of a data. So that obviously increases the more bandwidth to the user. So this whole thing is achieved by something called amplitude and QI amplitude and Q amplitude. So that's called IQ. So that's normally we use it as a single value as an IQ signal. IQ signal which gets modulated either into a 16 QAM or 256 QAM to increase the radio network. So this IQ word is more interesting, and it helps to achieve the higher data rates even in a 4G as well as a 5G kind of a scenario. So now we in the previous in this slide we can see that how the signals 256 QAM or 264 QAM we identified that many symbols can be packed and sent across. Now how do I say, so that is a one particular signal we talked. Now let's talk about a 10 milliseconds frame. So in a 10 milliseconds frame, so this is a one whole frame. So every 10 millisecond frame is called one frame because it has a 10 slots in it. Okay, each slot is divided into again, I mean, each subframe, one subframe is of the length of 1 millisecond. Okay. In subframe, I can further divide the subframe into one slot of 0.5 milliseconds. So in the 0.5 milliseconds, I'll have one bit like this. So there will be 12 subcarriers will be available in it. So if I take the whole picture into a picture, right? So there's a frequency of frequencies available that I divided with 15 kilohertz as a spacing between them, and I got 180 kilohertz of one particular pack here. If you have a 20 megahertz, you will have a 128 pack of so many items available to us. Now, in that one particular millisecond, one particular piece at a 180 kilohertz length is considered as a one subframe. One subframe is further divided into two slots, and each slot is of the length of 0.5 milliseconds, and it's called one resource block. And each resource block will have 12 subcarriers. So if you look at subcarriers will be there, which are of 7 symbols each. Okay, so that much of a data which can be packed in a particular 0.5 milliseconds of time on this small tiny data. Okay, so that's how we package the data, and each package, each item here can be quamed. I mean, like, you know. So for example, if we use a 10 megahertz signal, which will have a 600 subcarriers in it. Okay, how they are available is like here. So for example, so a resource bundle is 12 subcarriers, a total of 50 RBs are available to us. So 50 resource blocks get into a 600 subcarriers in them. Okay. So this is how the packets are packed inside that particular time slot of a frequency. Now, when you have so many symbols are available, can I use all of them for a data transmission? No. So if you use all of them for a data transmission, then only data will be there. There's no control, nothing will be there. So you need to understand what signal it is coming, what power it is coming, what modulation it is coming at. How many control symbols are there? How is it? First thing is whether the signal is getting transmitted here at the T or T plus delta, T plus delta delta. So we need to synchronize ourselves to the network first. The mobile need to synchronize radio network to the external network first. Then only it can start even talking to each other. So that whole thing is happening using a reference signal power. So there will be two blocks will be specifically dedicated for that particular one. One is called the primary synchronization signal and the secondary synchronization signal. So they are transmitted every first and the sixth subframe on the inner 72 subcarriers of a channel. So they get transmitted every now and then so that a user can synchronize themselves and automatically make a adjustment and understand the network, how it is, then they start transferring the signals. Okay. So once you understood and synchronized, now in a downlink, there are several logical, like, you know, it's like a physical layer, transport layer kind of thing. So in like here, we have physical channels which are available. In the physical channels, I can what to do with how to transfer the signal and what to transfer the signal. So these are the two things which are logical channels explains to us and the transport channels explain to us using the physical channels. So in the physical channels for the downlink, that means from eNode B to the mobile is PBCH, PDSCH, PCF, ICH, PDCCH, PHICH. So these are the signals, these are the physical channels available. So now whatever you want to talk to mobile using these channels only you need to talk. And in that, how to transport them you can transport using the DLSCH, RBCH or PCH. And what to transfer on that particular channels is PUCCH, BCCH, DTCH and DCCH can be done on that. So for example, you want to do a page control. So paging. That means there is a user is there in a particular area and he is dormant. He's not doing any activity. Now network wants to find him because it's always initiates from a network to the mobile, right? So he starts using a paging control channel. So he starts using a control channel using a PCH as a transport, and uses a PDSH as a physical layer and physical channel and transfers the signal. So when I say PDSH, it's a shared channel. PD means PD stands for a downlink, and S stands for a shared channel. But similar thing I'll have it at a PDCCH, where it's only control related information will be sent to the sent to the mobile. So this is about downlink organization. So in the downlink management, as I said, PDSH, we took an example, right, where how it will run. So now let's assume that there is a problem in you sent a signal to the mobile, and mobile need to acknowledge it back by using a HARC. Okay, so that HARC is or else if the mobile sent it to something to you and you need to acknowledge it. So that particular case, PCFI and a HARC indicator channels will be used, and they get transmitted automatically. So they basically, HARC is a way to make sure that your data is transmitted to across correctly and received at the other side correctly. Okay. So in a downlink, what else we broadcast? So in a downlink, we broadcast so many symbols here. Okay, for example, MIB, SIB are getting broadcasted. So MIB, SIBs are normally, they were existing in a previous generation also. So in the MIB is most essential part of the parameters required for initial access, the MIB will contain. And the SIB1 will have a cell identity, access related parameters, scheduling information of the system will be contained in it. And these gets transmitted every 80 milliseconds and 40 milliseconds respectively. So that they get proper, the UV understands the whole network and the physical layer. So once it understands, it synchronizes on a physical layer, then only it can start communicating with the network. So in the uplink direction, again, PUSCH, as I said, PU stands for uplink related one, SCH stands for shared channel, where data and control channel can be shared, and PUCCH is only for control channel will be shared. Okay, this is a logical organization of that particular stuff. Now let's come to the how the UV attaches to our network. Okay, so I think so this is a RACH process, how it will be. So there will be random access will be available, and PDSH will send a random access response, and UV identification is transmitted, and UV gets attached to the network. Similarly, so when a transmission across the multiple path, right? So when a signal gets reflected between a multiple walls, so that creates a multiple streams to the mobile, so where it has receiving the data, and it automatically gets reflected, and then automatically transmission request, and this thing will be done. Okay, so let me so TDD, we this is all about FTD stuff in TDD area. So we will, so there are some more things are there here in the scheduling thing. So in the attached sequence, we have default mirrors, all those stuff. So let me take you back to the, because of we are running short of time. So let's go back to the one video which I want to share, physical implementation of. Okay. So let's talk about the one thing which we do at this particular CommScope. So there is so when you go outside, it's called outside macro networks. When you come inside the network, so that's called to be indoor solutions. So indoor solutions are going to be multiple ways are there. One is called DAS system, which are purely CPRI based. I mean, we take a signal and transmit into digital formation and send it across to us. There's one more example is radio dot and tower related stuff, where basically basically they do a CPRI product. We take the whole radio system and they put it into across to the system. So that's a CPRI product which will just transfer the whole data into the network. Now there's an interesting which we do, which is more like a 5G kind of solution here. So here, this video, let's go through this particular video, which will explain more about how the 4G and reaching towards the 5G happens. Sunil sir, can you play this video for me? Sunil sir, can you play that video?
Yes, sir. Yes, sir.
Okay. Volume is not coming. Anyway. Ah. Yeah, now volume is.
Sir, are you able to hear the volume?
No, not able to hear volume.
Sir, is it audible?
There's one more example, is radio dot. Now it is audible. Radio system and then put it across to the system. So that's just now there's an interesting which we do, which is more like a 5G solution here. So here, this video, let's go through this particular video, which will explain more about how the 4G and reaching towards 5G happens. Sunil sir, can you play this video for me?
LTE capacity is bound to users by dividing the spectrum into contains PRP.
Vishal sir, कैसा था तुम्हारे?
Each PRP
Can you play that video?
Let's see how this works. One cell determines the location of user sites, measuring the strength of the signal. Using this information, the system defines a virtual users A, B, and C are in separate virtual sectors, fine, not interfering. Notice that multiple radio frequencies serve the same user into the signal element. The baseband controller is used without interference. Sends user A's data into resource block 1 for the radio port to user A. At the same time, it sends user B to the radio ports near user B. User C's data to the radio ports near user C. The system knows that each user is far enough from the others if the radio points can transmit to all three of them to the same resource block at the same time without interference. One cell just used PRB1 3 times. Call this 3x reuse of PRB1. For resource block 2, the system is able to create 4 non-interfering virtual sectors. Users D, E, F all receive data in PRB2. One cell is created 4 virtual sectors within a single physical cell, or 4x reuse in PRB2, without interference. Notice that PRB2 was sectorized differently to PRB1. Other small cells overlaps create interference. They have no way to coordinate use of resource blocks across different access points. In contrast, one cell does not create interference. Only overlaps between different PRBs. This gives the system flexibility to optimize the available spectrum in a highly granular way. On a 10 MHz channel with 4x reuse, one cell creates up to 200 virtual sectors every millisecond for increased capacity up to 300 megabits per second. Then in the next millisecond, the process starts all over again. In this animation, the radio points appear with the title, what the signals will come back. Discussions of 5G standards. But why wait for 5G? You can have the benefits of self-virtualization today, LTE, with one cell.
Are you able to hear the volume?
Yeah. I think it was okay. I think volume, yeah, volume was okay. I think that should be fine. I think you can start now.
Sir, video is over.
Yeah, good. Good. I think what we do is we will share that video in the chat session so people can watch it offline as well.
No problem, sir.
Okay. So I just want one last slide. I want to share. So related to 5G, why do we need 5G kind of thing? So I hope my sharing is coming. Okay, so there you go. Okay, so now what we have is okay. So I want to talk about a PTP, all the stuff, but we will talk about why do we need 5G? That's a question which people are looking for it, right? So right now 4G is giving us data which we need, but you know the latency is more high here. For example, when you send data, it goes only after 10 milliseconds to the destination. That's why you see that there's a delay in when I talk. You hear after some time. So, but in a 5G, when it comes to 5G, that latency, the jitter between them will get reduced. Jitter will remain constant, but latency goes down, so that it will automatically gives a better feedback of the data which we request. Other than that particular biggest advantage of a latency, normal increase of data rates and volume and the reachability of the signal is a standard evolution parts which we get it as part of a regular upgrades which we do. Okay. So this is a slide which talks about G node B, so in the case of 5G, it's called NG node B. So next generation E node B. We had a E node B A node B in a 3G, E node B in a 4G, and the next will be G node B. It's a gigabit E node B or a next generation E node B. So that's the things which we're going to see, and this is a standard for that particular one. Two modes that 5G going to operate. One is along with the 4G, so where you will establish a connection with the 4G network, and then your data pipe will be automatically migrated to 5G in the back end. So then the front end will be first you will still go ahead and attach with the regular 4G network, then migrate it to 5G. So, standalone, that's a non-standard mode, NSA mode. That's what we're going to see it in the near future, and SA will appear later. Okay. So this is a brief introduction about the subcarrier spacing. So we saw 15 kilohertz is the standard spacing in the case of 4G, but in our 5G we have a variable, and it's a TDD based, and they pack the symbols so tightly that you will end up doing a 1 millisecond subframe. Okay. So those are the things which we get, which we see more and more. I mean, if you look at the 240 kilohertz, right, spacing, so at that time we see that a one slot size will be 2.6 milliseconds against a 0.0 milliseconds in the current network which we have. So when the slot itself becomes so small, that means your action to the reaction will become more missing. Okay. So summarizes why we achieve 5G related data rates, how we achieve latency in the network. So this, and and obviously new radio automatically enhance the penetration as well. So, so that is it from my side, guys. Thank you for all your patience and listening to me. If you have any questions, please feel free to contact Sunil sir or me. We will be more than happy to help you. Okay.
Participants, if you have any question, you can ask Devraj sir. Participants, if you have any questions, you can ask sir.
Let me stop sharing.
Sir, I have one question on behalf of a user through the YouTube link. He has asked one question.
Okay.
The question is, can we solve 5G security threats on IoT? If yes, what are the possible permanent solutions?
So can you repeat one more time the question? 5G security threats in.
So the question is, can we solve 5G security threats on IoT?
Yeah.
If yes, what are the possible permanent solutions?
So the security is always going to be so even in a 4G itself, we have so many security layers. When a node talks to a security, when a mobile talks to network, there will be a ciphering done at the radio signal. There will be ciphering done at E node B to the MEB network, and there will be ciphering done between a PGW to the whole network. So there's a multiple layers of there will be encryptions will keep happening all the time. So in the IoT devices, because they are very small and we don't want to consume too much power on that particular stuff, so and we want to support a large volume of amount of devices. So that's why what we do is we end up doing a lot of compromises on this heavy processing. So, and there are some themes are available. So which probably I can share it in our next webinar, or whenever we get a chance, we can come across that and I can share it to you. We definitely by using encryption algorithms, we can solve the problems of this.
Sir, I have one more question on behalf of a user.
Mm-hmm.
The question is there health effect of 5G on biological body? I repeat, is there health effect of 5G on biological body?
Yeah, see, we are using a millimeter wave. So these are all, I mean, these are radio, and they are at a very short signal. There is a definite impact on a body, but there is no study which says that it has a negative impact on our body. Even if you go out currently, when you go into the open sun, there is a GPS signal coming, there's a 4G network signal is coming, there's a microwave is coming, there's a lot of radiation is already happening. And today also we are exposed to this radiation, and nothing is really happening to adverse the body. The 5G radio also will be like that. It will not have a major impact, but obviously it will be, we are exposed to much more radio signals.
So there is one more question. Hello.
Go ahead.
Sir, there is one more question through the chat box. The question is, how to identify large number of devices in IoT?
There's so IoT itself defines that BGPP itself come up with CATM is one particular scenario where large number of UEs are going to be handled. So in those cases, what we do, we don't allocate a full spectrum or a full protocol stack or a full ERAB related information to that particular kind of UEs. We take a shortcuts. We cut a lot of data. For example, in the CATM or IoT related devices, we don't keep completely POS. So we combine them and we allocate before the request itself, and we optimize our network resources, because the IoT devices doesn't need attention which we give it for a regular UV. So we cut out a lot of things from that particular stuff. So by using that methodology and by using a less session information for that particular one, by doing a less frequency polling of these particular UVs, we end up supporting 50 to 60,000 users on a given second. So that's how we support it. Okay, does it answer, guys?
Hello. Hello.
Yeah.
So there is one more question. There is one more question. Please brief about 5G security compliance and standards.
There's a bunch of information is available in for security related stuff, right? So in the case of 4G itself, when an eNodeB talks, when an eNodeB talks to a core network element, we use something called a strong span security gateways. I mean, strong span is just a free product. And each can talk to its neighboring module using the IPsec. So that means each and every layer is encrypted and secured over a tunnel. So man in the middle can't read the packet. The core network, they are pretty much free. They can pretty much tap anywhere data. But in the case of 5G, it's a provision is made, and there are a lot of provisions actually. One of them is this IPsec tunnel between the components itself.
Hello.
Go ahead.
Any questions from participants? Okay, sir. Then we'll wind up the session.
Dear participants, we are going to send the feedback link to your mail today. Tomorrow we are going to start the session of Engineer Raju Kulkarni, Technical Programmer Manager, Google, California, USA, sharp by 10:15. So be with us. Now it's time to vote of thanks. Good afternoon all. Myself, Professor Sankalp Mehta, Department of Computer Science and Engineering, KLECET Chikodi, takes privilege to propose vote of thanks. As all good things come to an end, so is the today's session of webinar. On behalf of KLE College of Engineering and Technology, Chikodi, I take this opportunity to thanks to those who have directly and indirectly contributed to this webinar series on recent trends in computer science and technology, organized by our Department of Computer Science and Engineering. At the outset, I thank you, our speaker and resource person, Mr. Devraj Patil, Engineer, Principal, Research and Development, Comscope, Bengaluru. We are really enlightened with your knowledge and presence, sir. I would like to thank our beloved principal, Dr. Prasad Rampure, for his enthusiastic support and motivation. A special thanks to our organizing committee, teaching and non-teaching staff for their unflinching support and coordination. Our heartfelt thanks to our all participants for their active participation. With these warm words and a kind message, we move to the end of today's session of webinar. Thank you once again. Thank you one and all. Thank you, Devraj sir.
Thank you, guys. So thanks for having me here. Thanks especially to Sunil for bringing me in here. I appreciate you guys. Thank you.
Thank you very much, sir. Dear participants, by afternoon, we will be sharing the feedback link. The feedback link will be sent via mail. Please give your feedback. And the next session will be tomorrow at 10:15 by engineer Raju Kulkarni. He is working as a project manager in Google Incorporation, California. I repeat, tomorrow 10:15, please join the second session of this webinar series. Thank you. Devraj sir, on behalf of entire CSE family and the KLECET Chikodi family, I thank you very much for sparing your valuable time and imparting the valuable knowledge with respect to 4G and 5G, sir. Thank you very much, sir.
Thank you, guys. Thank you. Have a good day, guys. Bye-bye.
Thank you, sir.
Sir,